Hey, good morning. We're starting to wrap up this multiplying of polynomials today. There will be a practice test tomorrow and then a test on Friday. So make sure notebooks are all aligned. Some of you have been absent a number of days. And so make sure you're keeping up with the study guides so that your notebook grade starts off this semester with a really good grade. All right. Here's a couple of problems. Number one should take you only a couple seconds of finding the trinomial. And then do FOIL on those following three there, or the distributive property on number 4. All right, I have the answers on the next page, so just pause your video, give it a shot, and let's see how you do. All right, welcome back. So, I got C, trinomial means 3. I'm looking for something for 3 terms. This one up here is a binomial. This one's not a trinomial because this guy right here can be multiplied together. And so the work there is not done. A lot of kids would say B is a trinomial, but really that you have to take that 5 times 4. Terms are divided by pluses and minuses sign, okay? And usually it's all done after we're all done collecting like terms and putting it in order, then we look for how many terms are, okay? This is called a factor. 5 and 4x are factors. All right. There's what I got for number 2, 3, and 4. Make sure again that you're putting them in descending order by degrees and that you know how to find a degree. All right, so let's move on today. Today we're working with some special binomials. And I'm surprised that kids last year didn't ever, or maybe never seen it, but they don't remember this commercial. It was a couple years back that some kind of computer program came out. Everybody's kind of amazed at what it could do, and so it kind of blew their mind is kind of what it was. And so it was kind of a interesting commercial that all these purple brains were blowing out like that. Anyhow, some kids are going to have their brains going to feel like that today is I don't get it. I don't know what you're doing. It's too risky. I'm not going to do it. I'm just going to do FOIL and move on with life. And that's okay. But we should start looking for some patterns here with certain binomials. Here's an image here, and this is what we're going to start working with is it said, let's take this a times an a because that's a square. If it's an a by an a, that'd be like a 4 by 4 or 12 by 12. That means it's a perfect square. And I multiply those two together, I get an a squared if I was trying to find the area of it. And that's what we're kind of doing is we're finding the area of polynomials. And they said, well, what if we stacked on another piece over here called the b? And so now my length is a plus b. And so that's what they got right there. And then they said, well, what if I did it this way? Because I wanted it to be a perfect square. So let's just say, for instance, that this was a 4. Okay. And let's say we added 2 to this. So that means this would be a 4 and this would be a 2. So 4 times 4 is 16. But now if I add 2 to it, now my side over here is a 6 and this is a 6. So it's a 6 by 6 now. So it's still a square. 6 by 6 is a perfect square. And so what they said is we're going to start looking for some patterns here that when I add these two guys and I multiply them, I see I got an a squared here, an ab over here, because a times b is ab. When I did b times a, I got another ab. And then when I did a b times a b, I got a b squared. Now if we did that over here, a plus b times a plus b, because that's what my length of my side is after I added it, and I get a squared plus ab plus another ab and then plus a b squared, and I get this unique number here. I get a b squared and an a, whoops, that's an a squared at the beginning there. So kind of we're looking for some patterns here. We call this a perfect square. When I notice that there's an a squared here and a b squared there, I know that this is a perfect square. Okay. Now we're going to look for some shortcuts, but before we look for the shortcuts, let's look for the pattern. So let's do FOIL for this first one here. X plus 4, X plus 4. Go ahead and do FOIL real quick. Interesting. Okay. No big deal there. I got an x squared and plus 8x plus 16. Let's go over and do this one. Y squared. Okay. Let's go down and do this one. This one's not written in standard form. We're not going to panic just yet. Put it in standard form. And let's do the last one. Now you're probably saying in your head, why is he making us do this? There's nothing new here. This is what we've been doing for the last couple of days. Stick with me. Okay, so let's look for some patterns here. Any patterns that you notice with the 4? Some kids would say, well, I notice that whenever I multiply these two numbers that are the same, I have matching numbers in the middle. I have 2 of them. That's true. I have 2 4x's in that first one, which added up to 8x's. This one, I have 6xy, which added up to, whoops, I missed a y on that one. 12xy's. Here I got 8. Bam. And here I got a minus 3 and a minus 3. They're the same all the time, the middle 2 terms on these. Okay. What else do we notice? Might say that I noticed that my first one's always an x squared, or it's whatever. Well, here it's kind of odd, but this guy here is squared. This is squared. If I took 3x and I squared it, I'd get 9x squared. If I took a minus m and I squared it, it'd be minus m times a minus m, which would be an m squared. And then look at the last term here. Isn't it this number here squared? Okay, I flip-flopped these two guys, so this is now the first one down here. But 4 squared is 16. He's over here because I wrote it in standard form. 9. If I squared that, 2 times 2 is 4. Y times y is a y squared. So when we call these perfect squares, and so we can kind of take a little bit of a shortcut. Here's the rule. Step number 1. Whoops, sorry. So might write it right in the middle here. Step 1. Square the first term. Step 2. Square the last term, or the second term. Now when I square the first term, that's going to be my first term here, x squared. When I square the second term, I'm going to leave some space because in my trinomial, he's going to be my last term. When I squared it over here on letter B, I squared 3x. 3 times 3 is 9. X times x is x squared. Then I squared the second term. 2 times 2 is 4. Y times y is y squared. But I want to leave some room for my middle term. Now, how are we going to get that middle term? Third step is multiply the two terms. So I took 4 times x. X times 4 is 4x, but I needed an 8x. So then I'm going to say, then, which is very important, whoops, multiply by 2. Because I always have 2 of them. I have 2 4s to the seconds. I have 2 4x's. I have 2x 6xy's. I have 2 of these. So I want to multiply by 2. So let's practice. It takes a little bit of practice. First of all, I recognize that it's a perfect square because I have x plus 6 2 times. So the first rule says square the first one, x squared. Rule number 2 says square the second one. 6 times 6 is 36. Now the middle term is the one that kind of could struggle with a little bit. I have 1x times 6, that would be 6x's, times 2. And you would get x squared plus 12x plus 36. Practice another one. Square the first term. Square the third or second term, but that's going to be my third term here. Take the 2, multiply them together. 5 times 1 is 5. A times b is 5ab's. Now 5ab's, in my head I'm thinking times 2 would be, that's a times sign, 10ab's. Now I'm going to put this one in order. I know this is going to be my biggest term here, so I'm going to go right for my final answer. So if I square that, that's going to be c to the 6th, because that'd be c to the third times c to the third, and I add my exponents. So that'd be c to the 6th. I square the second term, but really this is written backwards, so I'm going to put the 1 over here. 1 times 1 is 1. Now 1 times c to the third would be c to the third, and c to the third times 2 would be 2c to the thirds. Let's see, I got the answers on the next page. Let's see if we got the same thing. Yeah. Bam. Okay. So it's kind of like a shortcut. Again, it works on perfect squares. Now, if we look at this one, we notice kind of something a little bit different too, that I have a minus sign. Up here, these were all positives in the middle. Okay. So let's look and see if it works for the negatives too. If I did FOIL, and here I spaced it out. I did FOIL, I got a squared. I got a minus ab. Then I took my inners, I got a minus ab, and I got a b squared. Now, don't I have the same thing? Square the first one. That would be an a squared. I square the second one, but this is really a negative b. So a negative times a negative would be a positive b squared. And now when I multiply them, 1a times a negative 1b would be a negative ab. If I multiply that by 2, I get a minus 2ab's. So it works on perfect squares that have negative signs in the middle as well. Okay, so let's practice it that way. Step 1 says square the first one. X squared. Says square the second term. Now I'm going to call that a minus because I know in FOIL if I did a negative 5 times a negative 5 on my final one, I'd get a positive 25. Okay. Now the middle one says take the 2 terms. So I have a 1 times a minus 5. So that's going to be a minus 5x's. And I want to multiply that by 2. So that's going to be a negative 10x. My middle terms are always going to be negatives on these. Okay. My 2 leading term and my final terms are going to be positives. Let's square it. That would be 36 a to the second. Again, this is a part that's kind of a little bit weird. Negative 1 times negative 1 is going to be a positive 1. I want to leave some room for my middle term. Now multiply the two. 6 times a negative 1, 6a times a negative 1 would be a minus 6a's, and I want to multiply that by 2. So that'd be a minus 12a's. Save some time. Okay. Square the first one. Now I make it, I know it's going to be a positive. So again, look, if you're going to use shortcuts, you got to kind of think that way. That's a negative 3 times a negative 3. All right, so now 4 times negative 3, that's going to be a minus 12 CDs, because C times D is a CD. And then I want to multiply that by 2. Okay, now once again, kind of look at this. I see a d squared there, so I know this is a perfect square because I have a c squared and a d squared. But here I have x times x on my head. I'm thinking that's a perfect square. And isn't 25 a perfect square? 5 times 5? 36, that's a perfect square. 6 times 6, 1 times 1. So these are called, again, perfect squares. And we're going to be able to recognize these so that we can work backwards next week when we come back to school. Now, I want to go to my x squared because I know this guy is going to be my first term, and I don't want to do all this writing. I could say, okay, square the first one, that's 9. Square the second one, that's going to be a plus x to the 4th. Multiply the 2 together, that's going to be minus 3x squared times 2, so that's minus 6x squared. But now look, I have to rewrite everything. So sometimes, again, I'll shortcut things. I want to say that's going to be a x to the 4th. I'm going to square this one because really that should be over here. So that's a plus 9. And then my middle term is still going to be a minus 6x squared. Now I have it in standard form already. Okay? All right. Let's give it a shot. Do a couple problems here coming up, and we'll see how you do. Okay, let's see how you did. Uh-oh, my light went off. Just a second, I'll be right back. Okay, again, we always write our answers in standard form, so on that third one there, kind of be careful. All right, hope you did well. Now again, if you're kind of like saying, man, this is too many rules to memorize, that's okay. Just do FOIL, and it just takes a little bit longer to do, but it'll still work. Okay, but we also want to practice this at recognizing this so that when we go backwards on factoring, we take this trinomial and we go back to this, we will recognize that that's a perfect square. Now, this one's kind of a different, it's an a plus b times an a minus b. So this is not anything kind of squared. Up here, it was x minus a term squared. Perfect square. Up higher here, we had pluses in the middle. So we had pluses. So what we have now is something that's called the difference of two squares, because we have a minus sign on one and we have a plus on the other one, but they're very, very similar. Okay, so now let's just do FOIL here real quick and see what our answer is and see if we can make a shortcut. Notice that our x's in the middle cancel out, and we just have x squared minus 36. Interesting. Let's do it one more time right here. We got x to the 4th. Again, our middle terms cancel out, but look now if we can make a rule here for what we're doing here to get these two terms. So we're squaring the first one. That will still work. If I squared x squared, I get x to the 4th. But I'm going to kind of look at this. I know that if I do a positive times a negative, my answer has to be a negative for that third term. So right there, I know automatically it's going to be a negative, okay, because I've done enough FOIL. But look at, if I just square the 2, I get 4, and if I square the y, I get y squared. I know that my middle terms are always going to cancel out. These guys cancel out. Let's see on the first one here. If I squared the first, yep, I get x squared. And then if I know that my answer is going to be a negative, because positive times negative is negative, because a negative 36, so just square the 6. And again, I know my middle two terms are going to cancel out. So let's square the first one. 49. My last term is going to be a negative, because negative times positive is a negative, but I got an n squared. And I know, again, my middle two terms are going to cancel out. So let's put it in standard form. So if it was me and I was looking at this, I know this is going to be my first term, because n times n is an n squared. So I look at my n's and say, okay, it's going to be a negative, because positive times negative is negative, and it's going to be an n squared. And then I'm looking at my 7's, they're both positives, so it's going to be a 49. And again, I know my middle terms are going to cancel out. So let's practice. Taking the shortcut. It's a difference of perfect squares, because one's a plus, one's a minus. So this is a difference of two squares. Okay? So I want to square the first one. I know my middle terms are going to cancel out, so I want to square the first one. I know it's going to be a negative, and 8 times 8 is 64. Square the first one, but I want to put it over here, plus 9, because I know he goes second. And then I'm going to take these two guys and square them. Or you might even do it this way. 2 times negative 2 is a negative 4, y to the 4th. Okay, that'd be like squaring 2. 2 times 2 is 4. This one's written backwards, so I know it's going to be a negative r squared. And then I know these guys are going to be a plus 81, and I know my middle term is going to cancel out, because one's going to be a positive 9r, the other one's going to be a negative 9r. Okay? And you can see my answers there. Something got chopped off. All right, here we go. Now we got the Eureka math problems. Here's this koi pond surrounded by gravel path. Write an expression that represents the area of the path. So what we want to know is the area of this guy right here. So think about that for a second. They said my pond is an x minus 2. And then they said my big square here that goes all the way around is an x plus 2. So how am I going to find just the area of the path? Do you agree if I found the big square's area, I could subtract the small square's area, and then that would give me just this orange area, the path? So let's do that. Let's find a bit large. I want to say large over here, which would be x plus 2, and that would be squared, because it is a square. Small path is an x minus 2, and that is going to be an x minus 2 times an x minus 2. So I want to use the new rule that I just learned. This is like the very first ones we did. We're going to square the first one. We're going to square the second one. Then multiply the 2, which would be 2x's, and then multiply that by 2, so that's going to be plus 4x. This is that one that's the same thing, except for it's x minus 2 and an x minus 2. So I'm going to square the first one. A negative 2 times a negative 2 is going to be a plus 4. Multiply the 2 together, so that's a minus 2x times 2. Okay, now we said we were going to subtract the 2, so I want to line things up. X squared minus 4x plus 4. And now I want to subtract these guys, very important. Large square, take away the small square. So x squared minus x squared is nothing, they cancel out. 4x minus minus 4x minus minus becomes a positive, so it's going to become an 8x's. And 4 minus 4 is nothing. So my final answer is 8x. The area of the path is 8x Do we have any units? I don't see any in the problem, and I don't see any in the words. So I'm just going to write the word units. It is an area problem, so I need square. 8x square units. Okay. Here's a swimming pool. We want to find the area of it. Area is length times width. So I want to take the 5x, 5 plus x, and the 5 minus x. I want to multiply those. Now again, you can use FOIL, or you can remember the shortcut. Isn't one of these, are both these, the middle term, going to kind of cancel out? Okay, because they're the same thing, just one's a plus and one's a minus. So I'm going to go right for my final answer in standard form. It's going to be a minus x squared. I know my middle terms are going to cancel out, and 5 times 5 is a plus 25. Let's find the area of my little square. Do you agree that x times x is going to equal x squared? And if I want the total area of my swimming pool, I should add these two guys. So I'm going to put plus x squared. My x squareds cancel out, so it's just 25. And again, I don't think they have anything. So I'm just going to put units, and I'm going to put a 2 up there, square units. Okay? All right. So practice these guys. All right? Maybe try the shortcut. If you're not sure, do FOIL. Check it out. See if you can kind of do it by practicing. Let's take a look at some of our word problems here today. So they're breaking this one down for you. We said find the area of the large square. So it looks like it's a this and a this. That's the length of the sides. Then the second one says find the area of the small square. So you have to multiply these two guys together. And now they said find the area of the shaded. So you're going to subtract the two. Take the little guy away from the big one, and that'll tell you how much the shaded one is. I copied this one down for the second one from up above here because I couldn't see it. So it says the small rectangle in problem 19's diagram is made larger by adding 2 units to the length and 2 units to the width. So we're talking about the small rectangle. It's made larger by adding 2 units. So if I added 2 units, wouldn't this become A4? And I added it to both. I think it said the length and the width. So that's going to be 4 now too. So this one's in 4 plus x. And this one's a 4 minus x. So those are my 2 dimensions of my small one now. And they said, what's the new area of the small rectangle? So multiply those 2 guys. Put that answer here. And now they said, well, what's the area of the new shade? Well, you can go up to the big one. You already did the work for the big one up here. Hopefully you did it right. Subtract the 2, and you'll see the area there. All right, that's that. Tomorrow we'll do a chapter review. Practice test, and then Friday's a test. And we'll wrap up multiplying polynomials. All right, have a good day.